Welcome to this web lecture about the usability principle of error prevention. The most obvious way in which we will assure that users cannot make mistakes is by using constraints. With constraints, we make sure that controls that make sense at the moment, so actions that make sense to be performed, are enabled, and actions that make no sense have their controls disabled. Unfortunately, this does not solve all the problems because sometimes it is necessary to enable controls that may be used or may not be used, but we must make sure that it is unlikely to use the wrong control by mistake. The examples we see on this slide show cases where an error is likely to happen. Right? In the picture on the left, we see two controls in a car that actually, from the picture, explain why it happens that a car pulls up at a gas station, right? And then the trunk opens. And the trunk opens without the driver getting out to take gloves or something out of the trunk, but the trunk simply opens by mistake. This is caused by the lever to open the trunk to be right next to the one for the gas tank. And we all know the Windows control that you probably already hit by mistake, right? Where maximizing the window or simply closing it and perhaps ending the application are right next to each other. It's a standard, but it's a bad design in terms of error prevention. So the way that we try to avoid such mistakes can also be used to place controls in such a way or to create commands in such a way that dangerous actions that are not used a lot are hard to perform by mistake. The phone we see on the left, right, has an on-off switch that is placed right where you normally hold your thumb as you are calling. So, like if someone calls you, you pick up the phone, and it's for your friend or your wife, and you hand them the phone, it is likely that you will turn off the phone by mistake by trying to hand it over. The picture we see on the right shows a car seat, and in this model of car, the lever that you see at the bottom has a different function than you expect. In most cars, you pull this lever to pull the seat either forward or backwards. In this car, it releases the seat so that it can be removed from the car. If you pull this lever while you're seated, you will fall over backwards. This problem was easy to prevent, for instance, by disabling the function of the lever when someone is seated. That is not so hard to detect. In computer commands, we have similar issues. We typically make sure that dangerous operations are not just performed without any confirmation, or that they are made difficult to type by mistake. If you want to shut down a Unix system, you have to actually type the word shut down. You're not likely to type that unintentionally. However, a command like rm-rf/, which will try to wipe your entire hard disk, will be performed without asking for any confirmation. The best way to prevent errors in interfaces with hardware is to make sure that only controls that are actually used are present in the interface. We see lots of interfaces with unused buttons. For instance, TV remote controls. It is very likely that the remote for your TV has buttons that have no function with your TV. The reason is that they make one model of remote, and it has functions. It has buttons for the functions of the TV model that you didn't buy because it was much more expensive. The same thing happens in cars. On the dashboard, you probably have a number of buttons for functions that do not exist in your car because you didn't buy these options. We also see the problem in software, where different versions exist, and then the manufacturer deliberately enables menu items and toolbar icons for options that do not work because you didn't buy the more expensive version that has these options. So they're stimulating errors rather than preventing them, hoping that when you activate that function because it is what you want, right, and you do that by mistake in the sense that you didn't buy that functionality, they're hoping that you will then upgrade to the more expensive version. Whereas in fact, you will be frustrated and you will decide to buy a competitor's product instead. Finally, we always try to be consistent, right, with standards that exist. So when you are developing a new product and there are similar applications that use a certain standard, it is not realistic to expect your users to go against what they are used to. They will try to use the application as if it was designed to follow the standard, and they will run into trouble. People always fall back on their old habits, right? So they will take a long time to learn the new behavior of the application. Now, if you want to be inconsistent, you have to make sure that nothing is similar to what was known by the user before. This is important advice for your final assignment. You are going to design a thermostat. People in the Western world are used to how thermostats typically work. You now have the choice to either try to follow the standards they are used to, or to come up with a completely new design. If you only innovate part of the functionality of a thermostat, your users will have trouble because they will try to work with the thermostat the way they expect other thermostats to work. Thank you for participating.